We're going to call this video ChemistryA33ABlake. Yeah, to pick it up somewhere on Tuesday, probably Wednesday. So we are doing molecular formulas. How do you know when you do an empirical or molecular formula what goes first, second, third, etc.? There is an order that chemists usually use and agree on that usually goes this way, from least electronegative to most electronegative, ending with fluorine. This order in your book is a table on page 194, I guess. And the order is carbon, then phosphorus, then nitrogen, then hydrogen, then sulfur, then iodine, then bromine, chlorine, oxygen, and fluorine. Now, you can certainly find exceptions to this, but this is typically what we use. So when you run across exceptions, ask about it, please, and I will try to clarify that. Okay, so assuming we have done all these up to here in class, on number 62, and I'm on page 350. A compound was found to contain almost 50 grams of carbon, 49.98, and 10.47 grams of hydrogen. The molar mass of the compound is 58.12 grams per mole. Determine the molecular formula. Well, you have grams here, so you can go ahead and turn those directly to moles. If you had those in percents, you'd have to pretend you had 100 grams and make those grams and then go to moles. And then once you go to moles, you're almost home free because you can go to mole ratio and start figuring it out. So if you have 49.98 grams of carbon, and there's 12 grams of carbon per mole, this cancels. I don't have that on here, so grams carbons would cancel grams carbon. Please do canceling when you do figuring this out. It'll help you out a great deal. 10.47 grams of hydrogen, and there's 1.0079 grams of hydrogen per mole, so grams hydrogen cancels. And it becomes 4.161 mole of carbon, 10.37 moles of hydrogen. Divide by the smallest. You gotta identify which number is the smallest, because sometimes students mess that up. So it's 4.161 is smaller than 10.37. Divide them and you get 1 and 2.5. And pretty close to 2.5. And then you can see where if you double this, you get 5, and that would be 2 doubled. Double it, you get 2. So the empirical formula is going to be C2H5, but that may not be the actual empirical formula. So what you have to do is figure out what a mole of this would weigh, and then compare it to what they give you. So you have to figure this molar mass out, which might be virtual, it might be real. You don't know if this is going to be the answer. It's just your divisor or divider, I don't know. So 2 carbons times 12 is 24, 5 hydrogen times 1 is 5, total to 29. So you take the number they give you divided by 29, comes out to pretty close to 2, which this is what you're going to use to double. So you're doing this step to figure out your multiplier. Your multiplier may be 1, in which case your empirical formula is the right formula. Your multiplier might be 2, like it is here. Then it comes out to C4H10, which makes sense. This is butane, so this is an organic compound. Okay, going on to 63. A colorless liquid composed of 46.68% nitrogen and 53.32% oxygen has a molar mass of 60. What's the molecular formula? Well, they gave you per cents, so we need to change those to grams right away. Pretend we have 100 grams. So just make the per cents grams right away. Convert to moles, we'll say we had 100 grams. And when you cancel grams nitrogen, and over here you cancel grams of oxygen, your moles are about 3.33 each, and dividing by the smallest, which is 3.33. Make sure you know what steps to do next. So just to write this down isn't going to do you any good. You got to be able to predict what step comes next. So they're in equal. So it could be NO, it could be N2O2, it could be N3O3. You don't know at this point. So you take this and you find the molar mass again, which is going to be 14, and 16 is about 30. Okay? They give you a number of 60, 60.001, I think. When you divide 60 by 30, you get 2, so your multiplier is 2. So it's that times 2 and that times 2. It's N2O2, which is a compound we also came up with earlier this year, so we know that works. It's nitrogen 2 oxide, or dinitrogen dioxide. Actually, we didn't come up with that one earlier this year, but it exists. Okay, next one. Number 64. When an oxide of potassium is decomposed, 19.55 grams of potassium and 4 grams of oxygen are obtained. What is the empirical formula? Okay, turn your grams to moles. All right. Potassium is 39 grams per mole, so you got about half of one there. Oxygen is 16 grams per mole, so you got about a quarter of one there. Divide by the smallest, which is a quarter, and they're in a 2-to-1 ratio, so it's K2O, or some multiple of K2O. All right, that was number 64. They just wanted the empirical formula. They didn't ask for a molecular formula. Now, K2O, metal with the nonmetals, ionic anyway, you won't have a molecule for that, so you won't have a molecular formula. It's just going to be in this ratio. So that's going to be true for your ionic compounds. They'll always just come out to the ratio because you don't have a base particle. Like covalent compounds have molecules. Okay, 65. Analysis of the chemical used in photographic developing fluid yielded the percent composition data shown. So in the picture you have 65.45% carbon, 5.45% hydrogen, 29.09% oxygen. The molar mass is 110 grams per mole. Okay. So on that one, turn your grams into moles. Convert your carbon to moles. So grams cancels, convert your hydrogen to moles, grams cancels, convert oxygen to moles, grams cancel, 16 grams of oxygen, 1 of hydrogen, 12 of carbon. When you do that, you get, pause, figure it out, turn it on and check. 5.45, 5.44, 1.82. These two are about the same. This is the smallest. Divide them each by the smallest. You have to know to do that step. So your mole ratio comes out to be 3, 3, and 1. Well, is it 3, 3, and 1? Or is it 6, 6, and 2? Or 9, 9, and 3? Or 12, 12, and 4? What is it? Okay, take this, find its molar mass, and divide it into 110. Okay, and then when you do that, down here, usually I do that in blue, I get 3 carbons times 12 is 36, 3 hydrogen times 1 is 3, and oxygen at 16, and add it up, I get 55. The number they give me, 110 divided by 55 is 2. So your multiplier is 2. So it's going to be 3 times 2 is 6, times 3 times 2 is 6, and 2. So it's going to be C6H6O2, which could be any number of things. It could be a ring compound. Okay, let's try 66. That's probably where we'll end up. Morphine. Determine the empirical formula, and they give you 4 masses: carbon's mass, hydrogen's mass, oxygen's mass, nitrogen's mass. Turn all those masses into moles. And when you do that, it looks like this. Grams carbon cancels, grams hydrogen cancels, grams oxygen cancels, grams nitrogen cancels. And you convert these to moles. And then they are 1.49, 1.68, 0.264, and 0.0877. This is the smallest. Divide them all by the smallest. And the numbers you get are 17, 19, 3, and 2. Okay. I don't think they give you a molecular formula there. They wanted the empirical. They wanted the empirical, and that's it. This is morphine's molecular formula. It's don't have a chemistry, or I don't have a chemical structural formula for it to show you on here. I think I've got one in here somewhere. It's just not on this question. Okay, I think I'm going to end this video here, and we'll do one more for the section 4 review on page 350. I think its title is going to be ChemistryA33ABlake.